Hello, I'm Kirill Ushakov, and in this video I'll talk about consumer-driven contract testing. We will try to figure out what it is in a nutshell and why this can be an alternative to end-to-end testing. In this video we will learn some theory, and in the next videos I'll show some practical cases of using consumer-driven testing with a real application based on Mint stack. To understand the essence of consumer-driven contracts and how they help to test software, firstly, we need to take a look at the classic test pyramid. We see three levels of testing here. The first base level is unit tests. On this level, we test small pieces of code that can be logically isolated. The second level is integration tests. Integration tests are sometimes understood as tests that involve interaction with database, file system, or some external APIs. But speaking more general, integration tests determine if independently developed units of software that are parts of program flow work correctly when they are interacting with each other. And on the top of the pyramid there are end-to-end tests. These tests exercise most parts of the application and can go through all layers from the user interface to database, as the goal is to simulate being a final user of the product. To perform end-to-end testing, we generally need to build and deploy a full environment and whole application with all components, services and storages. The realistic nature of end-to-end tests makes them slow, costly and brittle. The wide coverage makes them less informative than unit and integration tests if failure occurred. You can read more about the test pyramid and its levels on Martin Fowler web resource. I'll add links under this video. For me personally, it's a very cool source of fundamental knowledge and understanding about software engineering, and I highly recommended it for any developer that wants to deep dive in theory. In the context of my project, the end-to-end testing will be going from web client interface through all layers of application to the database on backend. And we know that this kind of testing will be slow, costly, brittle, and won't give us a lot of information about practical bugs if something goes wrong. So the question is, do we really need this type of testing? Because on the front-end part with Jasmine and Karma we can do full test coverage to be sure that all is fine. And the same for the backend part, that can be fully testable with Mocha. So if we are sure that all is okay with front-end and backend with separating testing, can we be sure that these parts will work fine together? Unfortunately, we don't. The web client and backend communicate with each other via REST API. And to make this communication successful, we need to be sure that backend behavior and responding are corresponding to the client's expectations. And here where consumer contract-driven testing comes in. From the perspective of this approach, we can consider our web client as a consumer of service and our backend as a provider of service. In this case, API endpoints, format of request and response, will be a contract between consumer and provider. In this picture, we can see that we are using unit testing on both sides to verify the contract is being executed. So if you know that both parts are tested with their separate test suites and the contract between them is also verified, we can be sure that the whole system will work fine. And this is why we can remove end-to-end testing from our testing process. In the picture you can see arrows 2 and 4. This is important to understand that consumer is the creator of the contract, and provider has to implement this contract. In the practical part, I'll show you how it technically can be implemented and how the contract will look. For this moment, it is important to understand that consumer needs and expectations go first. This is why we are saying consumer-driven contract, not provider-driven or something other driven. The consumer generates a contract based on its expectations and needs. Pact is a code-first tool for testing HTTP and message integrations using contract tests. It has implementations for a bunch of different languages. You can see a long list of languages that are supported by Pact. In my work, I will use Pact.js, implementation of Pact for JavaScript. To be more precise, the name of the npm package is Pact Foundation. Let's look at what the Pact is really doing on the customer side. The first thing is mocking the provider, and this allows us to perform unit testing without real communication with the backend. The mock server has to have information about requests and responses that it will need to handle. In terms of Pact, the pair of request and response is called interaction. Physically, the interaction in my case will be present as a JavaScript object that needs to be added to a mocked provider before using it in unit test. The second crucial thing that Pact is doing, it generates a contract. Physically, a contract is a JSON file with description of expected requests and responses. The main work that Pact is doing on the provider side, it uses interaction descriptions from the contract to run requests against backend endpoints and compare results with contract expectations. For some test cases, we need to have a special states of provider. For example, we need to put some test data in database. And this is another important feature of Pact. It allows developers to set up predefined states of provider that correspond to certain requests. If we look at these two schemes from the official Pact guide, we will see a big distinction between scopes of CDC testing of consumer and provider. On the consumer side, we test only collaborators with external service. In fact, it will be pretty small and simple, highly isolated unit tests. But for providers, the test scopes are wider and include all flow from entry API points to repositories with mocking a database or using a real database. So this looks more like a complex integration testing. So we see a conceptual difference between CDC testing for consumer and provider. We use lightweight unit tests for consumers and heavy integrated tests for providers. In a common case, the consumer and provider can have different code bases and exist in separated infrastructures. To share contracts between them, we can use Pact Broker, the tool that allows publishing, sharing, and managing Pact contracts. There are also alternative approaches to publish and share Pact contracts. But in my application, I will use a Pact Broker that is hosted on the PactFlow web project. This project gives a convenient web interface for Pact contracts management. I think enough theory for a start, and in the next video I'll show you a real implementation of consumer-driven contract testing with Angular frontend, Jasmine, Karma, and Pact.js.